Astronomy Cast, episode 304 from Monday, April 29th, 2013. Death of a Spacecraft. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
It is morning. We don't record in the mornings. You're catching me on my first cup of coffee with this recording.
I think you can absolutely tell that I am the morning person of this team.
Yes.
I'm like, I'm bouncing off the walls. I've had my cup of coffee and I'm going a little crazy. So,
do you remember the threat I gave you when we went on the cruise last year?
Don't wake me up in the morning. Don't let the kids wake me up.
Any child that knocked on the door before 9 a.m. might be returned dismembered or at least tied up.
Thrown overboard, yes. Yes. And it was everything I could do because, again, my kids are morning people too. So we're all up at like 6. So.
Well, we're planning to go to Hawaii this year in January. So hopefully that will be my native time zone and things will go better.
Very cool. Should we make another reminder that we're going to be doing this all-you-can-eat CosmoQuest-a-thon?
Yes. So on on June 15th and 16th, starting at noon Eastern, which is GMT -5, we're going to do at least 24 hours of continuous science demonstrations, science education, speakers, panels, basically an online celebration of science that we're tying to a fundraiser to help pay for what we do with CosmoQuest. As any of you in the U.S. know, we're getting hit hard with governmental sequestration, which is the fancy word they use in the U.S. to say austerity measures. And we're also facing severe funding cuts due to restructuring of how education is done in the U.S. And all of this potentially means that all of the things that we do and all of the things that many other great NASA teams do are going to get defunded, which means we're out of work, the science stops. And so we're going to say, if you think this is important, donate. We think it's important, so we're going to work our butts off to show you what we're capable of doing for 24 hours.
And what's that date again?
It's June 15th, 16th, and all announcements for this are going up on CosmoQuest and on the CosmoQuest page on Google+.
Right, so definitely check it out on Google+. All right, so let's get rolling. So in the end, everything dies, even plucky space robots. Today we examine the last days of missions. How do spacecraft tend to die, and what did in such heroes as Kepler, Spirit, and Galileo? The missions, not the people.
Kepler's not quite dead yet.
Not dead yet. And this is the thing, right? This part, there are so many stories because most of the time, if you look back in the missions, they mostly die. In fact, you look at like what happened to sending missions to Venus or sending missions to Mars, that it's just disaster after disaster. And so I think we have a lot of material here. And spacecraft is a dangerous, it's a dangerous, complicated, risky venture, and we pay the price in human lives, unfortunately, as well, but definitely in robot lives.
But it's important to remember that mostly dead is not the same thing as totally dead. Mostly dead, you can sometimes recover from.
Maybe that's another show. Right, which is like just amazing spacecraft.
You actually have that one on the list.
Do I have that one? That's clever me, because that would be awesome. But that's going to take a little more research because those stories are a little more obscure. So let's sort of like wind this back and sort of start at the beginning of sort of what goes into planning and launching a spacecraft, and then how can things go wrong?
It's more a matter of what things can you count on not to go wrong. Anything can go wrong.
Well, of course. So what kinds of things have gone wrong for spacecraft in the past?
Well, the initial phase of danger is, can you make it all the way to orbit in an orbit that's actually useful? So you have problems ranging from failure to make it off the launch pad, although that's extremely rare nowadays. We've gotten pretty good at getting off the ground.
Have you seen those classic videos, where the rocket just kind of goes up for, for 20 feet and then just collapses down on itself?
Yes.
Right? And boom, detonates on the launch pad. Yeah.
So
want to be on the top of that spacecraft.
Past that form of failure for the most part. So then the next form of failure is, well, you had the initial stage of the rocket successfully fire, but then other stages of the rocket said, no, not going to work, and either fired wrong or failed to fire. And so the spacecraft didn't make it to the intended orbit, or it got steered wrong. And so now you have a misplaced spacecraft, and you have to figure out if you can rescue it from there.
And this happens a lot.
Yeah.
I mean, we're still, probably once a year, we're reporting on a spacecraft that didn't, a package of satellites or whatever that didn't make it to their intended orbit.
And the Russians had a whole string of these last year where either a fairing didn't come undone correctly or something didn't fire correctly and things just didn't make it.
Yeah, and so, I mean, then what do you do? Because you've got this, it's in orbit, it's working, in theory, it's functioning properly, but it hasn't reached its intended orbit. So
yeah, it depends on what the spacecraft was designed for. In some cases, having it in the wrong orbit, you live. You may not be able to do everything you had intended, but you can do most of what you intended.
And I guess it can shorten the lifespan as well, right? Because it might be so low that it's actually
drag.
Yeah, interacting with the atmosphere, and then it's just a matter of time before it re-enters.
But then there's missions like Phobos Grunt, which didn't make it where it intended, and then came back to Earth instead of making it to other planets in the solar system. So
that was not the plan.
That was not the plan. And when your interplanetary spacecraft doesn't make it to a high enough orbit, that's very hard to rescue yourself from. If it's a communication satellite, you may not be able to do the intended communications. If it's a space observatory, you just change how you get the signals back and forth.
And sometimes the price is a shorter mission that, normally you would be using all your propellant for reorienting your spacecraft and, moving it to different places during its mission. But if you have to use up all that propellant just to get you to your proper orbit, then you're not going to be able to use it later on in the mission.
Right, and so yeah, there's always the option of fire all your engines and get close to where you intended to be. So lots of things you can do. The question is, does this grunt, which came back to Earth? No, it didn't. But in other cases, they have been able to get spacecraft pretty much where they needed to go. And sometimes what's interesting is the changes in orbit are actually due to realizing that the intended launch vehicle won't work. So like the Chandra orbiting observatory ended up not getting launched on the launch vehicle it was intended, so it didn't end up in the orbit that was intended. It's a great mission that continues to return great science. So you just make things up as you go sometimes.
Okay, so we've got the situation where either the rocket detonates on launch, or the rocket, for some reason the upper stage doesn't fire properly, or it gets pushed into the wrong orbit. So let's say your spacecraft survives that. There's been situations where they haven't detached properly. The fairings haven't come off.
Yeah, so when the fairings don't come off, your mass isn't quite right, which means that when the thrusters you have for maneuvering fire, they're either not strong enough, they're not in the right place anymore to be useful, and there's drag if you're in Earth orbit, and if you're trying to get out of Earth orbit, that extra mass is a problem. So that's another way to kill a spacecraft.
All right, so let's say that we've successfully make it to space. We get onto our intended trajectory. Let's say we're going to Mars here.
Because Mars kills things.
Because Mars is where spacecraft go to die. So what are the ways that spacecraft can die kind of en route?
You can lose communication and just kind of end up permanently orbiting the sun as basically a new asteroid, just a man-made asteroid.
Right. So we've had that situation, right, where we've lost all communication. So the rocket works fine. Its thrusters are going great. It's on the proper trajectory,
we
and
have no clue where the expletive it is.
we just can't talk to it.
Yeah.
Yeah.
It disappeared from all radio contact. Can't find it because they're tiny. Yeah. So
Yeah. And I mean, we had a partial problem with that with Galileo, but because its main antenna failed, but it still had its secondary antenna, so they're still able to communicate with it. They just weren't able to send back great big high resolution images.
So that one didn't kill it. That one didn't cause it to get lost. It's when they simply go dark that it's a problem. And what's kind of crazy to think about is with a lot of these missions, they're pre-programmed in advance, and so you can lose communications with it for months on end, and suddenly it'll pop up completely fine, functioning somewhere else. That generally doesn't happen, but it's theoretically possible. So we keep looking when we lose communications.
Yeah, once we've lost communication with a satellite, the search for that spacecraft can go on for months sometimes.
Yeah, there's a lot of pre-programmed in, okay, when you see the sun here, the Earth will be here, so send a message. And there's a lot of what are sometimes called Lazarus modes, where a spacecraft will go into an extremely low power shutdown mode, and then periodically when certain conditions are met, will send a signal back, and that would allow us to resurrect it from the dead.
And you get these situations, where they go into the safe mode, right? And they, can they bring it back from safe mode?
And that's pretty much where Kepler is right now. And so this gets us to that great rotating problem in the sky, which is your gyroscopes.
Bring more gyros. Like, why won't anybody listen to me?
They take like 6 quite often.
Yeah, but maybe they don't report on enough of these stories. They don't see that it's always the gyros.
But they know it's going to always be the gyroscopes, and this is why they build redundancy into the system. But the issue,
what are these gyros? I think it's important for people to understand what these things are.
So they're spinning wheels. They're often basically flywheels, and because they're spinning, they're very hard to rotate, so they maintain their orientation. If you want to experiment with this for yourself, go find a bicycle tire, attach 2 methods of holding it to the axis in the center, set that sucker spinning, and if you try and rotate it, it will resist. And quite often, if you're sitting in a rotating chair or wearing roller skates, I don't know why you'd be doing that, you will move instead of the gyroscope. So in spacecraft, they will use these spinning gyroscopes to maintain their orientation, to keep track of their orientation. But when the gyroscopes fail, when they stop spinning, basically, if you lose your sense of orientation on the sky, you lose your ability to spin about a given axis, and ideally you want 3 of these suckers so that you can keep yourself oriented in all 3 of the X, Y, and Z axes. Pitch, roll, and yaw are the things that we worry about rolling about with the spacecraft, where you have to worry about the pitch around the one axis, roll around the other, and then yaw back and forth. So you need all of these gyroscopes going. You can make do with 2. Fuse, a spacecraft that was orbiting the Earth, figured out how to make do with 1 by using its magnetometer. I'm not going to say that word. Its ability to measure the Earth's magnetic field to figure out its orientation. But with Kepler, this mission that did go up with backup gyroscopes, these things that weigh a lot and require energy, it had the backups. It just didn't have as many as Fraser wanted.
8, 12, always more gyros.
It is now down to 2, and they're trying to figure out, okay, we have a mission that requires absolutely perfect pointing. We need to keep the stars exactly on the right pixels on our detector to be able to get the science we need to do done with this mission. And they don't currently have the ability to do that. So they have the mission in a shutdown mode. It is still functioning. It's still responding. They have it such that they'll pitch it over to look at the sun, not look at the sun, but point it towards the sun, and then the solar radiation will flip it back over. So it's basically moving in a known way so that they can check out the systems. They're communicating with it once a day, but it's not returning science.
Yeah.
And this is highly frustrating. So they have to figure out, can we get it doing science again, finding exoplanets again? Or, and this is where the ors kind of suck given the current economy, can we design a new science mission that it's useful for? Yes, probably. But once they figure out that new science mission that it's capable of, will there be the money to do that? And the answer is probably no.
We need a Kepler 2 and 5. We need 5 more of them. I mean, it is like the most important mission, one of the most important missions that's been launched in recent times. I mean, this thing will find, theoretically, another Earth.
Right, but yeah, that's cool. But at this point, we don't have the ability to do that much with the information. Look at what James Webb's capable of doing.
As a target for later on, for the next mission that's designed to, for the terrestrial planet finder. That's all. It's scouting out locations for the terrestrial planet finder, which that we are going to be bringing back from the dead. We will be resurrecting that mission with our clout in this industry.
So one of the frustrations is you want to have a whole suite of different instruments capable of a whole portfolio of different science. You want missions like Hubble and James Webb that are capable of numerous different projects, and we can't even imagine what we're going to fully be able to discover with them until we try. We know James Webb will be capable of studying the earliest galaxies, of studying the atmospheres of exoplanets. It's going to be this great mission for doing targeted science. We know we need things like the LSST, which is a survey ground-based telescope, so it won't die in space. But we need this whole suite of things. And yes, we do need the planet finder, but you can't say it's the most important mission. It's one of the necessary components to a complete portfolio.
Anyway, they won't bring enough gyros, so it won't be. So let's go on. So we've kind of gone down a bit of a rabbit hole here. So let's talk about some other ways. So we've loss of gyros. So we're going to go back to our spacecraft that's hurtling towards Mars, for example.
Yes.
It's made the journey. Obviously, it can get hit by it doesn't happen. It can get hit by micrometeorites.
Zotted by radiation.
And this has taken out spacecraft as well.
Yeah.
But the hardest part is the
not crashing into Mars.
Right. So let's talk about how that goes poorly.
Well, Mars seems to be this giant red planet-eating target of death. So we've run into all manner of difficulty, from things like the polar lander that had a unit conversion issue, so they didn't fire things when they should, and landed is a generous term, at a velocity far greater than intended.
A hard landing, as it were.
I think crash is an accurate word.
Right, so you get a situation where you're coming in too hot and you just smash onto the planet.
Yeah. Occasionally we have mystery forms of death. The Beagle lander that failed to make a very large dent on the surface. Folks with the HiRISE mission have pointed at potential crash sites. It's not really confirmed, although they'll talk about it in the bar. Yeah, Mars eats things. And
Oh, I was going to say, I mean, you can come in too hot and just smash on the planet, but you can also just come in at the wrong angle.
Yes. So you have to worry about, can you inject into the orbit you need? Can you brake on the atmosphere the way you want? All of these things start to matter. You can actually fly past the planet. We're pretty good at not doing that anymore. That was a problem in the 60s. We just missed planets.
Yeah, there's in sort of preparing for the show, you look at all the missions of Mars, aim towards Mars and missed.
Yes, now in solar orbit.
Didn't we discuss in the last show that a grade school kid was able to do the math to work out the trajectories?
There's a difference between doing the math and having your spacecraft actually obey because of a software glitch or a radiation eating a one that needed to be there. And so math is slow.
You couldn't hit
tedious.
the broadside of a planet.
That has been true before.
Yeah. Right. So you get these, they'll skip off the atmosphere, they're just coming at the wrong angle, or they just miss entirely. But let's say they do make it down.
Yes.
Land on the surface.
Yes.
How does it, how do they dive now?
Well, so you can end up with everything from the radiothermal generators, the RTGs, dying prematurely. That happened with one of the Viking landers. They can get stuck in the dirt. Spirit lived far, far longer than anyone thought it would. We have no complaints for how long it lived, but it did die a sad death. It was basically happily going along, happily doing science, returning great results, and rolled across sand that was softer than anticipated. And just like sometimes you'll be walking along in the woods and suddenly the trail eats your boot off your foot, well, in this case, it wasn't like Spirit could lift its foot and leave its wheel behind. It just got stuck.
Can you imagine Spirit like it had chewing its own robotic leg off somehow? If it had some kind of, if it used its rat tool on its leg and just kind of ground it away until it, it could keep moving. I don't know if anyone's thought of this. I'm pitching
Somewhere
this to NASA
there's a web comic now getting written about.
Yeah, but Spirit chewing its own leg off on the surface of Mars. Right. But as you said, Spirit was already suffering pretty badly. Was it the one that was dragging? It was dragging a leg.
That's Opportunity. Opportunity still happily dragging its frozenish leg behind. Yeah. I think it actually has
it should chew it off. But yeah, these are, at the end of the day, these things are mechanical machines. They're out on the surface of Mars. There's no repair coming.
And no one to come and tow them out of the dirt.
Yeah, they're gonna wear down, and so you get, mechanical failure. Maybe it could have pulled itself out of the sand if it had more.
No, it was just stuck.
It was just stuck.
And again, this was a mission where they figured out, okay, the sucker's stuck, and they tried so long. They tried. There was the whole free spirit movement to get it unstuck, but they couldn't. So when they realized the sucker was stuck, they turned it into a non-mobile science platform, and they pointed its cameras up. They did some astrometry work. They did all sorts of neat weather work, but then it froze to death. That is quite often the fate of things on Mars. So
let's talk about this. Yeah.
So computers, servos, pretty much anything that's that's mechanical or electronic has a preferred operating temperature. They don't like to be too hot. That's how Venus kills things. But they also don't like to be too cold. And when batteries get too cold, they stop charging. They start being able to give you electricity. Anyone who's been outside at night too long knows that your headlamp will start to freeze if you don't put the battery packet inside your jacket. And with Spirit, its system simply got too cold. In previous Martian winters, they'd been able to park it on an inclined hill so that it was maximizing the amount of sunlight that it got. And they were able to keep its temperatures above about -40. That's one of those temperatures that's not pleasant to experience, but a human will survive. Mm-hmm. But they think that final winter, when it was stuck in the sand at a non-preferred angle, that it probably got down to about -55 and just wasn't able to come back out. That when the Martian summer came back, it just wasn't sufficient to thaw things out, and the ability to charge things back up just wasn't there anymore.
And I think a more severe example of that is what happened to the Phoenix lander.
And that one they kind of knew was going to happen.
It was a suicide mission.
Yeah. This was the robotic version of One Way to Mars, One Summer on Mars. And they landed it in one of the polar regions. They knew it would shut down. They knew that it would get stormed on. And they figured it would get too cold, but it had a built-in Lazarus mode just in case it managed to stay warm enough and managed to conserve enough power to make it through the winter, and it didn't.
It didn't, yeah. Yeah, so it got, it must have gotten, it got snowed on, it must have gotten covered in snow during the Martian winter near the poles at, minus 100 plus degrees. It would have just been really devastating on the spacecraft.
Right.
So it wasn't a surprise they weren't able to reach it again come summer. But they tried. I remember,
they tried.
They were like, this isn't going to work, but we're going to try. Um, but now, we talked about mechanical failure, and you talked about the RTG sort of not working. But I guess, with something like Curiosity, what are the how will Curiosity probably die?
With Curiosity, it could unfortunately have any manner of unnatural deaths, ranging from getting stuck, getting over inclined, rolling over because it got over inclined. They have lots of safety modes to prevent that, but you never know. It's Mars. It could get impacted from space. That's never happened on Mars, but it would be cool if a random rock from space ate random spacecraft on Mars. Highly improbable. Most likely, it's just going to hit either a mechanical failure where it locks up and can't move anymore, or it's going to hit a power failure where it's no longer able to get enough battery signal going to communicate with space or rove its way across the surface.
But
That's
I mean, the
kind of its
nuclear.
planned form of death.
Yeah, I mean, it's got this RTG, power plant in it, and that's actually going to last it for, it could last it for a long time, years and years and years.
And the plan on this was at least hundreds of Martian days. Hoped for more than that. There's the occasional hope for thousands of Martian days. I don't think anyone quite goes that far. But eventually it's going to be lack of power that kills Mars Curiosity lander, unless it gets itself stuck or rolls itself over. Those are the two fundamental ways that it could die: is either a wheel getting stuck, mechanical failure, or it over inclines. But the built-in measures to prevent it from getting over inclined are huge.
Now, what about spacecraft like New Horizons? I mean, and I guess that's sort of similar as the Pioneers and the Voyagers, which they don't seem to ever die. Like, how long has the Voyagers been going for?
I
30
think they've been
years?
going for longer than I've been alive at this point.
Yeah.
So these are again spacecraft that have RTGs, nuclear powered, have the potential to get it's constantly diminishing amounts of electricity as they go through the half-lives of their fuel source. But as they're shutting off instruments, as they're going into low power modes where they simply ping back to Earth every once in a while, they're capable of lasting an extremely long time. With New Horizons, we have to fundamentally worry that we don't know what all is orbiting Pluto. And we're finding that there's more and more stuff orbiting Pluto than I think anyone imagined when they launched the spacecraft. So there is a very real, low probability, but still real and has to be thought about, possibility that this spacecraft is going to impale itself on a small moon, debris, or something else that will simply destroy it, hoping that doesn't happen. But other than that, its limitation is one of maneuvering thrusters more than end of life. So it's just going to keep flying for quite some time, just as the Voyager missions have.
Until they can't, they're not able to either, I guess, communicate with it if they get a power failure, or if they just can't orient it anymore. So could you have a situation, I mean, with the Voyagers and stuff, where they just get too far away that we just can't communicate with them anymore?
That is much more an issue of their signal is too weak to coherently make out. And that eventually will become a problem unless there's major breakthroughs in radio technology, which we can hope for. But I mean, imagine trying to hear your cell phone signal from Mars. We're going to hit that point eventually. And heck, my cell phone gets sad if it's in a farm field too far from the cell tower.
Yeah. But I guess that, I don't know, is that the sort of the final escape, right? That the spacecraft just got too far away, that nothing went wrong. It launched fine, it traveled fine, it did its mission, it was so successful that it just got so far away that we just couldn't talk to it anymore.
I would not be surprised if that was the final fate of Voyager.
That's amazing.
It's an amazingly built mission.
Yeah. Cool. All right. Well, thanks a lot, Pamela.
It's been my pleasure.
All right, save.
We didn't get to any of the cool ways they die.
Well, I saw that you're like, well, maybe this should be 2 episodes, but
because we missed like the whole purposeful destruction into planets, the purposeful destruction into the sun.
Oh yeah. Mhm.
Let's do a second episode and we'll just surprise everyone.
If you, but will there be enough?
Yeah, because we
Okay.
have to start talking about the biological issues.
Sure. Okay. All right. Well, we'll hash that out.
And now everyone listening, all two
You should put
people
that on the
out
list
there.
of things. I didn't see that. Oh well.
I said soft landing.
These are hard landings. Um,
Yeah.
crashing them into
You
planets.
got fixated with Mars. We never talked about the Venera stuff other than in passing.
Yeah, that the environment was too crazy. Um, yeah, that's a good point. Ah, well, you can't produce an Emmy-winning podcast every time.
I'd settle for doing that one once.
Ever. Okay, ever. Maybe you can't do ever.
Hey, if we can just get a parsec, I'd be happy.
Parsec. Oh, yeah, we've been nominated for another Parsec. I don't think I have the spirit to do it, to
I
to,
asked
to
Preston
apply.
too.
Okay, all right. Um, okay, I have saved mine.
I
I'm
have
gonna
done the
make
same.
I'm gonna make sure it's uploading. Then we will interact with the poor viewer still watching us. Oh, are you still sleepy?
Yes. I was telling Fraser earlier, I have Lafferty's new book, The Shambler's Guide to New York City, and it's excellent. And this is a problem because I figured yesterday while making coffee, yeah, I'll just see how it starts, read a couple. No, I'm like 150 pages in or something. And yeah, I
There
was up late reading last night. Damn you, Merv Lafferty.
you go.
I
Read your
say
new
that with
book.
love.
Read Myrtle Lafferty's new book. Okay, so
Yes.
any comments? Orju notes that it was because they couldn't convert to metric in America. So that's exactly what happened, right? Is that you Americans don't use metric,
No, it's a
and
problem.
it is a problem. But right, so what happened was there was two teams, right? There was European team and there was American team, and the Americans were doing all their work in imperial, and the Europeans were doing everything in metric, and they forgot to convert when they merged the code together.
And one of the ironies is when I was working at Astronomy magazine, I got an article on the polar regions of Mars from someone who I won't name, and every single unit conversion in the article was done backwards.
And Orju also notes that I need an RTG powered car. Yeah, you absolutely do. An RTG powered car would be fantastic.
Yeah,
It would
I
just
don't
be.
want cancer.
But you never have to refill your car, and this
No,
is, I
but
think.
I look at the Teslas. They're building the supercharge stations
Mhm.
all across the United States. Buy a Tesla and never pay for fuel again. You just have to plug in now and then.
Yeah. Michael Jobin wants to know if the Voyager gyros are still good. I don't know. I mean, yeah, I would
They,
assume. Does it use
I
gyros?
think
Does it
it
use
might have.
thrusters?
I think that it's just kind of there's nothing unstabilizing it, so it's good. It's not like it has to point. I mean, the
Hmm.
problem with all of these other missions that require all the gyroscopes to be functional is with telescopes, you're constantly moving that sucker around to look at different parts of the sky. And it's that constant motion that requires all the gyroscopes. I'm not sure you need to have that much. You
Right.
may be able to simply say the sun's over there and use your thrusters to center on the sun with something like Voyager.
GeForce 833 says, "Why do we use the Pacific Ocean to crash old satellites into? Bring some down in the Atlantic or the Indian, because the Pacific is becoming the great toilet bowl of dead spacecraft." So why do
Well,
we use the Pacific?
because the Pacific's bigger.
Bigger.
I mean, you just want to have a giant target, and so everything gets junked into the Pacific because it's a much bigger target. Also, think about it. Um, with the Atlantic, you have a very small space between North America and when you start hitting Northern Europe. Then there's a bigger gap between South America and Africa, but it's still the type of gap where a log with lizards on it can eventually make it all the way across.
Right.
This doesn't happen in the Pacific. There's just little tiny archipelagos. So, yeah.
Yeah, and it also depends on sort of the way the orbit goes, because you can kind of move, from over the United States all the way down towards Australia. And so you got a big long stretch that you could be ditching a spacecraft in. It really just depends on your orbit. I guess if it was a polar mission that only went over the Atlantic Ocean, they would ditch it in the Atlantic.
Yeah, you don't have orbits that work that way.
Well, no, you can. I'm just saying, if you had, I can't think of any reason why you would want to, but you could have a polar orbit that it's just, running from the North Pole to the South Pole right through the Atlantic Ocean, and then
But there's no way that it wouldn't go over both oceans. You
I
can't have an orbit that only, okay.
But then you could. If you're like, it's equal time.
No, Pacific's still bigger.
It's still bigger, I guess. That's it. That's all the comments I've got right now. That's because we popped up at a strange time. So next, let's look at our calendar. I'm going to look at my calendar because I can look at my whole calendar and you cannot be sent to an insane asylum.
Right. So I have us on my calendar
at 10:30.
Right. So right. So that's prep time. So I think that means start at 1 p.m.
Or should we just do noon 1?
Right. Okay. Sorry. 1 p.m. your time, which is 3 p.m. my time. Or we could do noon, which is 2 o'clock my time. So it's like the same times as Monday.
Why don't we do that? Let's do the noon.
Okay.
Okay. All right. And I would like to do the crazy successes as opposed to more depressing failures, like the...
I want to do more depressing failures and then do the successes.
All right. I'm not sure we have enough for a show, but we'll talk about it.
Well, we can also talk about how like epoxy got repurposed. So the undead missions that had interesting endings.
Ooh, you said a keyword.
Undead.
Undead missions.
Zombie spacecraft.
I love it. Okay. All right. Well, we'll talk about it, and we'll come up with something for tomorrow. Okay.
Okay.
All right. Well, thanks everyone for watching. Thanks, Pamela, for bringing your brain, and we will see you. We'll see you tomorrow, I guess. What's this? Voyager is spin stabilized, says Nick.
Okay,
Revoltis.
that's how they do it.
Yeah.
So the entire spacecraft is a gyroscope, basically.
And Audrey says that Pamela gets a mention in this month's UK version of Astronomy Now in relation to you, Wingate.
Oh, awesome.
Very cool. Okay, all right. Well, we'll see you all later.
Yes. So on on June 15th and 16th, starting at noon Eastern, which is GMT -5, we're going to do at least 24 hours of continuous science demonstrations, science education, speakers, panels, basically an online celebration of science that we're tying to a fundraiser to help pay for what we do with CosmoQuest. As any of you in the U.S. know, we're getting hit hard with governmental sequestration, which is the fancy word they use in the U.S. to say austerity measures. And we're also facing severe funding cuts due to restructuring of how education is done in the U.S. And all of this potentially means that all of the things that we do and all of the things that many other great NASA teams do are going to get defunded, which means we're out of work, the science stops. And so we're going to say, if you think this is important, donate. We think it's important, so we're going to work our butts off to show you what we're capable of doing for 24 hours.
And what's that date again?
It's June 15th, 16th, and all announcements for this are going up on CosmoQuest and on
Astronomy Cast, episode 304 from Monday, April 29th, 2013. Death of a Spacecraft. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
It is morning. We don't record in the mornings. You're catching me on my first cup of coffee with this recording.
I think you can absolutely tell that I am the morning person of this team.
Yes.
I'm like, I'm bouncing off the walls. I've had my cup of coffee and I'm going a little crazy. So,
do you remember the threat I gave you when we went on the cruise last year?
Don't wake me up in the morning. Don't let the
It,
kids wake me
it
up.
was any child that knocked on the door before 9 a.m. might be returned dismembered or at least tied
Yeah,
up.
thrown overboard. Yes, yes. And it was everything I could do because again, my kids are morning people too. So we're all up at like 6. So
Well, we're planning to go to Hawaii this year in January, so hopefully that will be my native time zone, and things will go better.
very cool. So should we make another reminder that we're going to be doing this all you can eat Cosmo Quest-a-thon with like just amazing spacecraft
You
propellers.
actually have that one on the
Do
list.
I have that one? That's
You,
clever me. Because that would be awesome. But that's going to take a little more research because those stories are a little more obscure. So okay, so let's sort of like wind this back and sort of start at the beginning of sort of what goes into planning and launching a spacecraft, and then how can things go wrong?
it's more a matter of what things can you count on not to go wrong. Yeah, anything can go wrong.
Well, of course, of course. So what kinds of things have gone wrong for spacecraft in the past?
Well, the initial phase of danger is, can you make it all the way to orbit in an orbit that's actually useful? So you have problems ranging from failure to make it off the launch pad, although that's extremely rare nowadays. We've gotten pretty good at getting off the ground.
Have you seen those classic videos, you know, where the rocket just kind of goes up for,
Yeah.
you know, for 20 feet and then just collapses down on itself,
Yes.
right? And boom, detonates on the launch pad. Yeah. I
So,
wouldn't want to be on the top of that spacecraft.
past that form of failure for
Yeah.
the most part. So then the next form of failure is, well, you had the initial stage of the rocket successfully fire, but then on the CosmoQuest page on Google Plus.
Right. So definitely check it out on Google Plus. All right. So let's get rolling. So in the end, everything dies, even plucky space robots. Today we examine the last days of missions. How do spacecraft tend to die? And what did in such heroes as Kepler, Spirit, and Galileo? The missions, not the people.
Kepler's not quite dead yet.
Not dead yet. So, and this is the thing, right? I mean, this part, I mean, there are so many stories because most of the time, if you look back in the missions, they mostly die. In fact, you know, you look at like what happened to sending missions to Venus or sending missions to Mars, you know, that it's just disaster after disaster. And so I think we have a lot of material here. And spacecraft is a dangerous, you know, it's a dangerous, complicated, risky venture, and we pay the price in human lives, unfortunately, as well, but definitely in robot lives.
But it's important to remember that mostly dead is not the same thing as totally dead. And mostly dead you can sometimes recover from.
Maybe that's another show. Right?
Other stages of the rocket said no, not going to work, and either fired wrong or failed to fire, and so the spacecraft didn't make it to the intended orbit, or it got steered wrong, and so now you have a misplaced spacecraft and you have to figure out if you can rescue it from there.
And this happens a lot.
Yeah.
You know,
yeah.
I mean, we're still, you know, probably once a year we're reporting on a spacecraft that didn't, a package of satellites or whatever that didn't make it to their intended orbit.
And the Russians had a whole string of these last year where either a fairing didn't come undone correctly or something didn't fire correctly and things just didn't make it.
Yeah, and so, I mean, then what do? Because you've got this, it's in orbit, it's working, you know, in theory, it's functioning properly, but it hasn't reached its intended orbit. So
yeah, it depends on what the spacecraft was designed for. In some cases, having it in the wrong orbit, you live. You may not be able to do everything you had intended, but you can do most of what you intended.
And I guess it can shorten the lifespan as well, right? Because it might be so low that it's actually
drag.
Yeah, interacting with the atmosphere, and then it's just a matter of time before it re-enters.
But then there's missions like Phobos Grunt,